Welcome back to Neural Intel. Today, we're diving deep into a really fascinating technical challenge.
Oh, yeah.
How do we really know if an AI truly understands a video? I mean, specifically, its ability to reason through events step by step, kind of like we do when we watch something unfold.
Ah, right. Step-by-step reasoning in video.
Yeah.
That's a tough one. And actually, we've got our hands on a compelling research paper about just that.
Okay.
It introduces something called VCR-Bench, a brand new benchmark designed precisely to test this kind of detailed reasoning in video AI models.
VCR-Bench. Okay, the name's interesting, but why do we even need another benchmark? What are the current ways we evaluate this? What are they missing?
That's a great question, and it really gets to the heart of it. The paper argues there are two main problems with how we currently assess video understanding.
Two main problems. Go.
First, you know how large language models have gotten much better at reasoning using chain of thought?
Connie?
Yeah, it's showing their work, essentially.
Yeah.
Models like DeepSeek, O1. Exactly. They generate these intermediate steps. Now, when we try to apply this to vision language models for video, well, the existing benchmarks,
Yeah.
they mostly just check the final answer.
Mm-hmm.
They don't really look closely at those crucial COTI reasoning steps.
So it's like getting the math problem right because the final number matches, but the whole calculation was like totally wrong.
Precisely. The paper is this great news anchor example. Picture a video, multiple people. One is an anchor.
Okay.
A model might correctly say there's one news anchor. Fine. But its internal reasoning might have completely missed the actual anchor and misidentified someone else.
Wow. So right answer, completely wrong process.
Exactly. So just looking at final accuracy, it doesn't give you the full picture. Not even close.
That makes sense. Okay, and the second issue you mentioned, something about perception versus reasoning. Are benchmarks mixing those up?
They are. That's the second key point. Current benchmarks often find it hard to separate the model's ability to just see things in the video.
Like identify objects, motion.
Right. That's perception. Separating that from its ability to actually reason about those things over time. It's one thing to see a ball rolling. It's another thing entirely to understand why it rolled, maybe who pushed it, where it might go next. Existing benchmarks don't always tease those two apart very well.
Okay, this is where it gets really interesting then. So tell us about VCR-Bench. What's the core idea? How does it tackle these problems with evaluating video COTI reasoning?
Well, the absolute core innovation, I think, is its use of detailed, manually annotated reasoning steps for every single sample.
Manually annotated. So humans wrote down the steps.
Yes, exactly. Real people went through and broke down the logical steps needed to answer the questions about each video. This ensures the ground truth. The reference steps are highly accurate.
So it's not just question, what happened, answer this. It's here's the question, and here's the 5-step thought process a human would use to figure it out from the video.
Precisely. And that allows for a much more detailed evaluation. We can actually compare the model's generated reasoning steps against these human steps.
Evaluating the whole thought process.
The whole chain, yeah. Not just the final link.
So what would you say are the main contributions VCR-Bench is making here?
Okay, several key things. First, like we said, it's the first benchmark specifically for video K that provides these detailed step-by-step justifications. That's huge.
Right.
Second, it introduces a proper framework for actually evaluating COTI in video. It gives researchers a standard way to measure performance at each stage.
Methodology.
A methodology, exactly. And third, the paper presents extensive evaluations using this benchmark.
And what did those evaluations show? What are current models good at or not so good at?
Well, the results show some pretty significant limitations, actually. Even the big state-of-the-art models often struggle.
Really? Where specifically?
Particularly with tasks needing detailed understanding across both space and time. Tracking how things move, how their positions relate to each other as the video progresses, that temporal-spatial stuff. And maybe most importantly, they found a strong positive correlation between the quality of the model's WT steps and its final answer accuracy.
So better reasoning really does lead to better answers. It validates the whole approach.
It absolutely does. If you want better answers, you need to fix the underlying reasoning process. It's not just about the final output.
That's a critical finding. Okay, let's get into the weeds a bit. This VCR-Bench dataset, where did all of the videos and questions come from? It sounds like a big undertaking.
It was definitely comprehensive. They carefully picked data from a whole range of existing video benchmarks. Figure 2 in the paper shows this nicely.
So leveraging previous work.
Exactly. Smart reuse. They pulled from datasets focused on basic perception, like perception test, next video, TV bench.
The fundamentals, seeing what's there.
Right. Then they added datasets testing more complex stuff like subject knowledge and reasoning, video MMU, MMVU.
Bringing in outside knowledge.
Correct. And for longer videos, understanding narratives, they use things like video MME, long video bench, plus data sets focused on temporal aspects like activity to captions for finding specific moments.
Pinpointing events in time.
Yeah, and review-S videos. And finally, video espresso for scene reasoning, understanding interactions. It's a real mix, designed to be well-rounded.
Looking at table 1, the stats table, anything jump out at you there? Size, types of questions?
Yeah, a few things. They've got a good mix of video lengths, short, medium, long. That's important for testing temporal reasoning at different scales.
Makes sense.
Over 1,000 questions total, split between multiple choice and open-ended. But what's really interesting is the breakdown of the human reasoning steps.
Oh, yeah.
A significant chunk are classified as visual perception steps compared to logical reasoning steps.
What does that suggest?
Well, it might suggest that a big initial hurdle for these AIs is just accurately seeing and interpreting the visual information correctly over time, even before they get to the complex logic part.
Interesting. Perception might be the bigger bottleneck initially. And these questions, they test 7 different aspects, right? Figure 3 shows these dimensions.
That's right, 7 distinct dimensions to probe different facets of video KT.
Can you walk us through them quickly?
Sure. First, fundamental temporal reasoning, FTR, basically understanding event order, what happened first.
A simple sequence.
Then video temporal counting, VTC, counting things over time. How many times did the red car appear?
Okay. Counting.
Video temporal grounding, VTG, finding the exact moment something happens. Pinpoint when the person waved.
Timing.
Video knowledge reasoning, VKR, using external knowledge plus the video, like based on the tool shown, what's likely being fixed.
Got it. External context.
Temporal-spatial reasoning, TSR. This is about tracking movement and position changes. Where did the ball end up relative to the chair?
Space and time combined.
Then video plot analysis, VPA, understanding the story, the why. Why did the character leave the room?
Narrative logic.
And finally, temporal-spatial grounding, TSG, locating an object in space at a specific time in the video, like where was the cat at the 15-second mark?
Okay, that sounds challenging. Very specific.
It is. It requires integrating both aspects precisely.
So a very thorough breakdown. Now, how does VCR-Bench actually evaluate the reasoning within these dimensions? How does it score the COT?
Right, the evaluation. It breaks the reasoning down into those 2 core parts we mentioned, visual perception
Seeing things over time.
and logical reasoning.
Drawing conclusions from what's seen.
Exactly. And the human reference steps are also tagged as either perception, AR, or reasoning.
Okay, so you can compare model perception steps to human perception steps.
Precisely. And the same for reasoning steps.
And there are specific metrics for this. You mentioned recall, precision.
Yes, 3 main metrics.
Yeah.
First is recall. Think of it as, did the model's reasoning mention all the important steps that the human reference included?
Coverage, basically.
Coverage, yeah. There's recall for perception, recall for reasoning, recaller, and overall. Equation 2 shows the math. It's about the proportion of reference steps the model correctly hit.
Okay, so recall is capturing the necessary stuff. What about precision?
Precision looks at it from the other side. Of all the reasoning steps the model did generate, how many were actually correct and relevant?
So not making stuff up or going off on tangents.
Exactly. Avoiding errors and irrelevant steps. Again, you get precision scores for perception, precision reblip, reasoning, precision recall, and overall. Equations 4 and 5 detail this, considering correct, incorrect, and irrelevant steps produced by the model.
Makes sense. Accuracy of the generated steps and the F1 score. How does that fit in?
The F1 score, equation 6, is just the harmonic mean of precision and recall. It gives you a single balanced number.
A combined score.
Right. It balances capturing all the needed steps, recall, with making sure those steps are accurate, precision. It's the main COT quality score they use.
Got it. But VCR-Bench doesn't just look at the reasoning steps, right? It still cares about the final answer.
Oh, absolutely. Final answer accuracy is still evaluated. They actually use GPT-4o, another powerful model.
Using an AI to judge an AI.
Sort of, yeah. They use GPT-4o to parse the model's potentially long, messy, cozy output and extract just the final answer.
Ah, okay. For consistency.
Exactly. Then that extracted answer is compared to the human annotated correct answer.
And for those grounding tasks, VTG and TSG, where the answer is like a time window or a location.
Right. For those, they use intersection over union IOU. It measures how much the model's predicted time segment or bounding box overlaps with the correct one.
With specific thresholds for correctness.
Yep. 0.7 IOU for VTG, time, and 0.5 IOU for TSG, spacetime.
Okay, let's talk results. Tables 2 and 3, figure 5.
Oh.
What did they find when they tested actual models using VCR-Bench?
Well, the results are quite revealing. First, there's a lot of variation in KT quality between different models.
Yeah.
And honestly, the overall scores aren't super high yet.
Nobody's acing this test.
Not by a long shot. The O1 model got the highest 2T score, which was 62.8%. Generally, the bigger closed-source models perform better on reasoning.
That's maybe not too surprising, though.
No. But interestingly, models were more likely to miss important reasoning steps than to generate wrong ones.
So precision was generally higher than recall.
That's exactly what they found. Suggests the models might be hesitant or just not thorough enough. They omit steps more often than they hallucinate fad steps.
Incomplete rather than inaccurate.
Yeah, that's a good way to put it. Another key thing. Logical reasoning generally scored better than visual perception across most models.
Ah, back to that perception bottleneck.
Seems like it. Accurately extracting and interpreting that dynamic visual info seems to be the tougher part compared to the subsequent logical deduction, on average.
And you mentioned the correlation.
Yes, figure 5 shows it clearly. A very strong positive correlation, R equals 0.89, between the COT quality score and the final answer accuracy.
Wow, 0.89 is high.
Extremely high. It really drives home that better intermediate reasoning directly translates to better final answers. Evaluating CO isn't just academic. It predicts performance.
Any other interesting tidbits from the results? Model comparisons?
Yeah, they noted that models known for better instruction following, like Quinn 2.5 VL versus some LVLM variants, tended to get higher COT scores.
So being able to follow the COT prompt format helps.
It seems to, yeah. Suggests instruction tuning plays a role in unlocking this kind of complex reasoning.
And how did performance look across those 7 different task dimensions? Any were particularly hard?
Oh, yeah. Table 3, the accuracy breakdown. Temporal-spatial grounding, TSG. That one stood out.
The one locating objects in space and time.
That's the one. Accuracy was really low there, even for the best models. Pinpointing things precisely in a video stream is clearly still a major hurdle.
That makes intuitive sense. Okay, what about things like video length or different ways of feeding input? Tables 4 and 5 cover that.
Right. Video duration. Generally, performance was best on medium-length videos.
Not short or long. Why?
Well, longer videos likely have more complex temporal stuff going on. Maybe the lower scores on short videos are partly because those TSG tasks, which are really hard, often use shorter clips needing high precision. Just a guess.
Plausible. And input settings.
That was pretty stark. Comparing the full video input with KT prompting versus, say, text-only input or just a single frame, performance drops significantly without the full video context.
Confirms video is necessary for video Q&A. Shocker.
Well, yes, but it quantifies how much it matters. And also, using QT prompting helped the stronger models more than the weaker ones.
So QT isn't a magic bullet for a weak model.
Seems not. The underlying model capability needs to be there to really leverage the step-by-step prompting effectively.
The paper also has qualitative examples, right? Figures 9 to 15. We can't see them, but can you give us a flavor? What do they show?
Absolutely. These examples are super valuable. They show actual model outputs, successes, and failures for each task type.
Concrete cases.
Exactly. Like for fundamental temporal reasoning, figure 9, you might see a model get the event order right, but miss a subtle visual cue. For TSG, figure 11, the snake example, you see just how hard predicting those coordinates is. The model's predicted box might drift way off.
I can imagine.
Or, for video knowledge reasoning, figure 14, maybe a question about magnetic permeability of metal rods shown in a video. A model might give a plausible-sounding physics answer, but its reasoning steps show it completely misinterpreted what was actually happening visually.
So the why behind the answer is flawed, even if the answer sounds okay.
Precisely. These examples really highlight why just looking at the final answer is insufficient, and why evaluating the reasoning process gives much richer insights into what the model actually understands or misunderstands.
This has been incredibly illuminating. VCR-Bench really seems to push the evaluation of video AI forward significantly. As we wrap up, what are the main takeaways for our listeners?
I think the biggest takeaway is that VCR-Bench provides a much-needed, more granular way to evaluate video AI, focusing on the process of reasoning, not just the outcome.
The how, not just the what.
Exactly. This chain of thought evaluation reveals strengths and weaknesses, especially highlighting that perception extracting spatiotemporal info is still a key bottleneck.
Right.
And the strong link found between co-quality and final accuracy proves this focus is critical for building better models. We need AI that not only gets answers right, but gets them right for the right reasons.
Understanding the how guides improvements.
Precisely. It opens up avenues for more targeted improvements in model architecture and training.
Fantastic. For those listeners eager to dive even deeper into the technical details, the VCR-Bench dataset, the metrics, the research paper is available on our kits. What aspects of video reasoning evaluation do you think are most critical? Or what errors seem most important to fix in future models? Let us know your thoughts. And definitely check out our webpage, linked in the bio, to stay updated on the latest AI and ML research. Thanks for tuning in to Neural Intel.